All right, so welcome to Formations and Solutions of Geosystems Engineering Problems. My name is Masha Pradanovic, and I'm gonna be with you this semester, and hopefully I will teach you a little something about A, what numerical methods are and why are they useful in engineering, and B, how to implement one on your own. And that is done in software called MATLAB, which is why most people call this class MATLAB class. So technically, we're actually learning how to numerically solve problems, and that could be done in any other software as well, not necessarily just MATLAB. All right. So we're going to today discuss Syllabus, which I hope you have a copy of. If there are some missing ones, I'm going to make more copies for next time. And we will sort of start with the introduction and motivation for this course. So technically it's going to take us to complete this introduction, it's going to take us to two class periods. So we will be done by Friday. So my name is, again, Masha Pradanovic. It's kind of probably foreign to you, both my first and last name. So I respond to a lot of things that are similar to my name, so you can mispronounce it and mistype it up. I'm probably still going to respond. So Masa is how it shows up written when I send you an email and in any kind of official documents. However, that's where this little thing about S was taken off, which makes it short. So whatever you do, just when you actually talk to me, don't say Masa. Masa in Croatian, which is where I'm from Croatia, means mass. I don't like being called mass. Masa in Spanish is also masa farina, which is the corn flour used for tortillas. I don't like being called that either. So please at least learn that my name is Masha, and whatever it is that you do to my last name, I'm gonna live with that. Okay? If you don't wanna pronounce my full last name, I do respond to Dr. P as well. So most of my graduate students call me Dr. P, and you may as well. So whatever you're comfortable with, I do respond to it. Okay. Now, good news about this complicated name is that if you do type in, if you know how to type my name into Google, I'm the only Masha Pradanovic there is. So there's no another person, so if you get a link, it's probably something to do with me. Right? You can find my website here. You can also just go to PGE website, and there's a link to my personal website there if you want to learn a little more about my background. And email me at masha@utexas.edu, so you can see that I will often sign myself with an H, which officially is not there, but I use it a lot, so that you actually can say Masha. Okay, so just a quick note about my background. I got my bachelor's in applied mathematics at University of Zagreb, which is in Croatia. Then I moved to the United States for a PhD in computational applied mathematics from State University of New York in Stony Brook, which is on Long Island, about 50 miles east of New York. And then I moved to Texas. I started as a postdoctoral fellow, then moved into a research position called research associate, and I've been professor at UT Austin starting 2010, and just this semester I'm starting in a tenured position called associate professor. So my research interests are in flow and transport in porous media. I specifically use a whole lot of imaging on a very small scale, basically micron scale, which is scale of your hair, to image microstructure of rocks. And it can get quite complicated. So here on the picture, you can actually see this gray is actually walls of a sandstone, and fluid moves through these pore spaces that are inside, and here you can actually see trapped blobs of gas within that pore space. So this is the residual saturation of gas or oil that we're typically after. A lot of primary drainage in reservoirs will leave about 30 to 40% of oil behind. So basically those are the little blobs that are trapped in the pore space that we're actually going after. So one can study I do a lot of image analysis to extract these structure and characterize them, and as well as simulation to actually come up with what does that residual situation look like. And also some sediment mechanics, fracturing, ferrohydrodynamics. In all of these problems that I work on, numerical methods or how to solve physical problems using computer plays a large role, and some of these methods have, the moment you have an established method, it's going to get a name. Some of them are called level set method, lattice Boltzmann, network flow, and discrete. So this is sort of like advanced stuff that you're going to learn later. This course is essentially introduction to the world of numerical solutions, so you can build. It's something that you will build upon later. Teaching assistant is sitting up here, Ningyu Wang. So would you like to say a note about yourself?
Well, if you have any problem, you can just go to Dr. Berdanovic or just come to me.
So we respond the best to emails. I don't list my phone number. My phone number is listed on your syllabus, but I rarely respond to phone. I'm either not in the office. If I'm in the office, I'm very likely in a meeting that I tend not to interrupt to pick up the phone. So it's much better actually if you email me and the response will be faster. So Ningyu will be here with us every class. He will also grade homework and any projects. So if you have a trouble with grading, you first go to him. So the way rules are, may as well talk about it right now. So you will get a certain number of homework projects and then you will grade them. As long as he's fair, he might be strict. I don't know, are you strict? Perhaps, we'll see. Okay, so he wants to put his poker face on. I care that if he's strict, it's fine, as long as he's strict for everybody. So basically, if he takes points off, he has to have a good explanation why he took them off. And if that, as long as that explanation was equally applied to everybody, I stand by it. So you first dispute any grading issues with Ningyu, and then if issues still remain, then you come to me. Okay, so I'm the ultimate resolver of disputes, but again, when a person tries to grade quite a large number of homeworks here, you try to be equal, and I'm not there. If I'm not grading, then I don't know all of the details, and he is the best one to respond to any initial issues. All right. And then solutions will be posted, homework solutions will be posted on Canvas within, that's not 2 days, within 8 days, apologies. And again, let me know if those solutions don't appear. So you are going to be checking on him as well and report how is he doing to me. So if the solutions don't appear on time as they should, let me know, and then I'm going to poke Ningyu to do it faster. All right. So let's quickly review syllabus. So you have all of these things that we're going to talk about printed there. So there are exams, quizzes, and homework. Exam times have already been posted there. I'm going to bring actually a copy of the syllabus here on the screen.
Is that you diving, Professor?
Just a moment. What did you say? So basically, exam has already been scheduled for Monday, 17th of October, 6 to 8 p.m. And I'm in the process of reserving a room. And Thursday, November 14th. So I will ask you to go, possibly you don't have your schedule immediately, but by the end of this week, to verify that these times are all right with you. I sat down with Arletta, and to my knowledge, this should really minimize any other possible courses you might be, or overlap with any other courses that you might be in. Please let me know if that's not correct. The reason why we have to deal with that this semester is that I have to reserve a classroom that can seat all of you double seating. That's not this classroom. It's a large classroom somewhere on campus, and I gotta compete with the entire campus for those. So there's a lot of people on this campus, and scheduling gets difficult. So please check your schedules immediately, and once these times are set, I cannot move them. Certainly not easily. Okay? So by the end of this week, please verify and let me know if these exam times work or if they're colliding with some other lecture or recitation or something that you might have. And then final again also cannot be moved. It's already scheduled to be on 13th on December again because this is a very large campus and all of these exams have to be administered in places that are twice larger than the actual lecture hall where they were held. That of course causes quite a scheduling task for the entire campus, which is the reason why this cannot be moved. It's essentially So we will also have some quizzes. There will be a number of unannounced quizzes. So they will typically happen at the very beginning of the class. If you miss them, you miss them. If you anticipate that you might be out of class, so for instance you're traveling to a conference or something that you really, or you have an interview or something that you know that is scheduled already, then you email me before. Please don't do the following. The class passes, then you hear from your friends that there was a quiz, and then you email me, by the way, Dr. Pradanovich, I had this in this schedule. So I do expect from you, and that's basically teaching you how to do things professionally. If you already know that something is happening, okay, and that if your schedule will be somewhere else, just say, this is just a quick note, I will not be in class, just in case there's a quiz, you're then going to be excused. Okay? And if you're excused, I'm simply not going to count that quiz in the final computation of the final grade. That clear? So again, it's learning how to communicate. Things happen. Also, you might be on the way to campus and yes, your car breaks down or something of that sort. Just quickly, that's something that you could let me know afterwards because you weren't anticipating it, of course, but let me know as soon as possible. So in terms of grading, and then homework, there will be approximately 8 to 10, depends on how the semester goes. Assignments, and there will also be a computational project sort of near the end of the class. So we will actually have at the end you will actually have 2 weeks to complete the computational project because it's a little larger assignment that doesn't necessarily fit into single homework. And once we do have it, then basically, since it's going to take 2 weeks to complete it as opposed to 1 week for homework, it's also going to weigh double the homework. So homeworks and projects will take 20% of the class, quizzes will be 5%, and then exams will be worth 20, 25, and 30% respectively. So in case that any of this, so typically we will assign a homework and it's due in a week. In case that something happens, again, that is unexpected or possibly expected, if it's a holiday, please let me know, so let's work with it. So if it's something that you know immediately, then let's deal with it immediately. And if it's something that shows up unexpectedly, as life sometimes does, please come by and sort that out. So then, now that we're talking about homeworks, your schedule this semester will get hectic as we move along. And then, of course, there are deadlines, and there's more that you can possibly fit into your day that you need to do. And then it's extremely tempting to copy your homework from a friend, if that friend allows you to, of course. Please try not to do that. Copying is actually, especially this class, will have a lot of code. And it's actually rather obvious in code that it's copied. Second thing, will do a lot of coding, and it's gonna be done on computer. Computer lets you know when you're trying to execute the code, oh, something's wrong, please try to fix. And then you go fix, so you can play with it and fix it up and then make it work. In the exam, however, there's no computer. Problem with computers is that they communicate, and I cannot let you communicate during your exam. Okay? So in essence, it's gonna be on a paper. So you will have to write down a piece of code that works on paper. Take some practice. So if you keep copying homework, yes, you're gonna have your, and presumably you do that in a way that we don't catch it. It's gonna catch up with you during the exam time. Okay. So work on your homework. And I think this also goes for any homework. A lot of the problems that you're working on are problems that are solved problems. They're known problems, there's some sort of fundamental problems either in science or otherwise. And there are solutions out there. There are solutions maybe from previous year, there are solutions in a different textbook. There are always solutions that you could possibly copy. But even if you, and sometimes you need to consult with the solution. But the procedure that you should do is this following. First, think about it on your own. Get confused, slam into a wall, go through that process. Because it's your retention of the material later will be much better and you will learn much better if you pose some questions. So work on it first day, doesn't go well. Work on it second day, and it's probably gonna go better, okay? And maybe you're still confused, then you actually go and ask a question. You ask a friend of yours, you ask me, you ask myself, okay? And feel free to ask questions. There are no stupid questions, you're learning. Okay? So after that, the moment you pose the question, sometimes you will actually see the solution. So there's a process to it. And then even if you have to either re-show you how to solve it or you see the solution somewhere else, fine, go through it and then put it away and try to do it yourself. And that's what you submit as your homework. Okay? Even though you actually consulted some existing solution. And most likely you will consult a lot of existing solutions. But the procedure there is that basically you have to be involved in the process, otherwise it's extremely difficult to learn. You'll be like, oh yeah, that sounds about right. And then when I ask you to do it yourself on the exam, you will run into trouble. So do it for yourself. Don't do it for me. All of your grades, they're for yourself. They're not for me. So this is a long story short. Turn only your own work and clearly state otherwise. And again, working through the problems is a rewarding experience, and it's simply you will remember better if you work through it yourself. However, if I do catch copying, I turn in copying, and I did that in the past. Does everybody know what happens when I turn it into Office of Students? It's on your record. So every time somebody wants to offer you a job and asks for a transcript, you're going to get a copy of it. That's not going to work. Never does. Second thing, what happens if I do it once and then another professor from this department later on does it again? You know what happens? You're out of the university. Okay? You get suspended. Is it worth it? So first, this copying will actually cost you much more when you actually prepare for exam. And second part, you will be after 2 violations, and we had that happen in this department. So don't let that, when I say read academic dishonesty rules, read them, know what the consequence is. Alright, so this is University of Texas. That will benefit you, the fact that it's strict place, that will benefit you down the line. People recognize the name University of Texas, and they recognize it for a reason. So there are certain high expectations in behavior that actually comes with it, so we expect that you're going to live up to it. So that doesn't come no change in the world comes from copying, that's for sure. Okay. And the rank of this department is constantly within the top 2. Okay. Graduate and undergraduate programs. So for graduate, we're constantly #1. For undergraduate, we kind of switch places with that other university in Texas. I can't remember the name. My memory is sometimes, I'm bad with names. You'll actually see I'm bad with names. Good news is that you can always retaliate. So when I don't remember your name, you can mess up mine and call me something else. So none of this actually comes out of the thin air. You have to work hard to maintain the ranking, but it's that ranking that then works for you once you actually go and look for a job. So if there is any dispute, so with graded homework, with quiz, project, and so forth, please try to, if possible, dispute within a day. Officially, we will actually take, and that's on what's printed on your syllabus, we will take disputes within a week. Okay? After a week, the homeworks have been returned for you, or the test has been returned to you. We can't. It could have been modified, there could be all kinds of things that happen, so we cannot take disputes after a week. Okay. So official deadline is a week, try to do it within a day. So I'm trying to modify. So I'm gonna clarify that because your syllabus says within the final. And part of it is there is a reason to it, and it's called memory. If I graded the exam, I had certain rules where I deducted the points, okay? And I'm trying to equally apply them to everybody. Okay? I might not remember those well after a week. So simply certain details of the memory will fail me, and then I'm going to be uneven in the way I apply a grade, and that I should be. So there is a reason why there is a time limit on all of these. All right. So feedback, you can talk to me, you can email me. You can also go to the anonymous feedback form, and I'm going to exemplify it quickly. So certain issues, you come in as you and you want to be responded as you, and certain issues you don't necessarily feel comfortable being identified. And there are some issues like that. Then anonymous feedback form is for you. You don't sign yourself, I don't know who you are. And I'm going to exemplify that. So if I go online to this form, okay, this is what you will see. And it says, please provide any comment or feedback or so forth. And then you type in something and submit. And I'm going to now show you what I see on the other end. If I can get to my, okay, where's my drive? I can't see my Google Drive now. All right. All right, so I'm gonna see. So what I will see on this other end is simply a spreadsheet. You can see actually previous responses. So there is simply a timestamp, and hello. Okay? So I will not say, unless you sign yourself, I will not know who you are. So if that's a more comfortable way to submit feedback, please do so. I often ask for some type of feedback, so you can see, for instance, questions. Can we write small MATLAB scripts for ourselves on our cheat sheets? So you can submit questions of that. So this is basically from previous time that I taught the course. Again, feel free to use it, and I will then respond either in class, or I'll find some other way to respond, or it might be just for my knowledge. Actually, these can get. All right. So you can apparently it's open to everybody to see previous responses. So some of it I was asking how long it took you to solve a homework, and apparently 2 to 2.5 hours is the time you should expect to solve the homework, right? So there is essentially, you can go. I might turn that off for privacy issues, but yeah. All right. So communicate. Any questions about syllabus before we move on and go to order? Okay, I'm going to verify. Yeah, that is. So a correction to the syllabus right now. This is a Monday. It's a typo. It means it was a Thursday last. All right. Any other questions? All right. So let's quickly introduce what it is that we're going to work on. So our course topics are as follows. So first we'll have introduction, and we will do linear algebra overview. So maybe you had a linear algebra, maybe you're now having it in 427J. Is it 427J? But we'll kind of review it anyway without counting on you having it somewhere else. And then we will start with just MATLAB fundamentals, how to work in this specific software. But again, you will learn how to do things in MATLAB in this course, but that the concepts remain, so you should be able to do or work or function in any other software or programming language. I'm not sure what's going on with that. That said, that means that probably the time for the bell for this class will not be on time, so if you see me going over time, say something. Say Dr. Bernardovich, hello. Then we will go through basic programming concepts. Again, we will apply things in MATLAB, but those concepts and loops and parts of a code remain actually the same in any programming language. And we will learn 90% of every programming is actually debugging or beating out errors. So we will learn about errors you cannot avoid and those that you can, and those are called debugging. And then we will actually be prepared, so we will have our tools ready to actually do some numerical methods that help solve problems that might not have a formulaic solution or solution in form of an analytical formula. So it'll be root finding zeros of functions, systems of linear equations, curve fitting, numerical interpolation if time permits, which in the past most of the time it didn't. Okay? And then numerical calculus, which is essentially essential way how to take derivatives and integrate in numerically, and ordinary differential equations. So if you are in ordinary differential equations right now, for one, you will actually know most of the stuff that you need to know by the time you get them, but we will actually not need anything that you do in ODEs because we will solve ODEs numerically. That's the whole point. So I will show you an alternative way to solve equations in this class. So even if you're not caught up with that other class, you should be good to go. All right. So course materials, lecture PowerPoints, handouts, everything will be posted online. I will typically note that. So on Canvas, you will see in files, you will see a folder called lectures. Textbook is Applied Numerical Methods by Chopra, but you don't need to have it. Essentially, the materials that I post should be enough for you to catch up with class. But if you like learning from a textbook or reading a textbook, by all means, get a textbook. And then there's an alternative one that is just slightly different approach. Okay? So you're not required to purchase a textbook. And I'm going to remove this typo right now. All right. Software is also free for UT students. So you don't need to do it necessarily immediately, but you can to prepare for later in the course. We will start using it in about a week or so, a week and a half maybe. So you just go on this link and you click on the tab called Students. You will need University of Texas email address to register. And once you do, then you will be able to download MATLAB to your own laptop. I will have about 30 laptops available here in class once we start needing them. So if you don't want to carry your laptop around campus, it is an option that you check one out. So just make sure to have your UT ID on you so you can check a laptop. And please do not have, so for tests, this is for tests, we will need a calculator. Please do not, we don't allow programmable calculators, just the basic one. Okay, and this is just installation detail for later on, but I may as well mention it right now. So when you're installing MATLAB, it's going to ask you for all of these additional toolboxes. We don't need any special toolbox, so you can omit them all. But if you have space on your computer, you may as well just install them all because you might need them later on. Okay? So they might come in handy later in other courses in this program, but we will not need any of the special toolboxes. So for instance, symbolic toolbox might be actually helpful for calculus. So you can integrate complicated stuff and get a symbolic answer as opposed to some specific number. So if you want to use it, though in calculus class they're probably telling you cannot. So, but if you want to double check yourself, right, then this could be actually helpful. Okay? All right. So just to introduce what computation actually means and what does it mean in regular life. So basically we have scientists, they're seeking to understand sort of nature in very basic elements, and they typically isolate a single event and study it in a lot of detail. And then they research sort of these very fundamental laws of nature. What do engineers have to do?
They apply what scientists have to.
They have to apply, and that often means that they have to work in much worse conditions. Okay? So scientists can actually isolate something in a very specific, like a specific reaction, isolate the temperature and pressure, and make sure that that's what's happening in the little dish, and observe what's happening, and find out whether certain laws are correct. Engineer, so let's say that you're now a petroleum engineer. Do you have a control on temperature at 3 kilometers down the hole? You should know what it is, and sometimes you don't. Okay? So when you have certain measurements of temperature at 3 kilometers of depth at various parts of the world, and they by and large should be in a good estimate, but a specific temperature in the reservoir or the future reservoir, if you're about to drill, that you will actually find out is not known. It might be warmer because there might be a source of heat somewhere nearby. Or you might be in a basin that has certain boundary conditions that are containing the temperature that's slightly different than it is 200 meters away. Okay? So you really know precisely, so, but you have to work with it. And that's essential difference between a scientist and an engineer. They're essentially working with the same laws of nature. It's just that one is studying them in detail and the other one is applying them. And again, you have to design and build things that actually work with these laws. Okay? You also have to often, in difficult situations, you have to find out which laws are the ones that you actually need to look into. So one example is that often, so you're in this morning, it's the first day of semester, first thing I needed, I don't know about you, it's a cup of coffee. I take my coffee with milk and sugar, thank you, and the moment I put sugar, okay, I gotta stir my coffee to actually enjoy sugary coffee, sweet coffee. Why? If I waited for sugar to get around my coffee cup, how long would I wait? 2-3 days. Okay? So it's not that mass transport of sugar in my coffee is not happening. It's happening. It's just happening at a time scale that is not practical for me. So I gotta go in with a little bit of convection to help it out. Okay? So you have to know about momentum transfer as well as mass transfer, but you also have to know which one is actually dominating the situation you're in. And that will simplify, because if you go and spend 2 months coding, trying to, do the calculation about the mass transport that ultimately you don't need, you have essentially wasted your engineering time. You have learned something, but you have wasted your engineering time. So in that sense, you need to know which law is important and which one you can neglect for the circumstances that you have. That's actually also important in petroleum engineering. So to give you a petroleum engineering example, I have shown X-ray tomography image of the pore spaces in sandstone at the very beginning. Those are on the micron scale, micrometer scale. So that's 1/1,000,000th of a meter. Okay? And they're typically, those pore spaces are typically 10 to 100 microns. Right? Those are the pore sizes in a typical sandstone. So in sandstone, actually momentum transfer, or just simply convection, that happens because, I have a higher pressure at one end and then lower pressure on the other end, so I'm going to flow from high pressure to low pressure. That's momentum transfer. That's going to be typically dominant in that type of a size. Now enter shale, and shale is an important resource nowadays in the United States. Okay? Those pore spaces are 1,000 times smaller. So they're actually in nanometers. On nanometer scale, especially below 10 nanometers, and some of them are below 10 nanometers, actually mass transport is kind of catching up with momentum transport in terms of time scales. So you cannot ignore, if you're looking at the total flux, you will have some of it that is driven by the pressure difference, and some of it that is driven by the concentration difference. You have to add them up to get the total. So suddenly, you actually have to know about mass transport as well, because it might be in the calculation, it might be significant. Okay? So again, you have to know which laws are important to figure out the behavior of the system. And we can never really isolate things. Okay? Our reservoir is what it is. It has pressure, it has certain pressure, it has certain temperature, and we can't just say, well, let's turn off something and see what would happen if I turn off one of the two. You typically have to have everything at the same time, so integrate rather than isolate. Okay. So out of all of the different engineering types, petroleum engineering or petroleum engineers deal with the most extreme situations. So if you just think about measuring pressure in biomedical, right? Finding a device that measures blood pressure, right? You're working in this temperature most of the time, or maybe up to 110 or so, 120, maybe 500 degrees in some extreme places, okay? And that's what your device should be rated for. Well, temperature in reservoirs, whatever it is on surface, it grows by 23 Celsius degrees every kilometer. So if you're at 3 kilometers of depth, your temperature is 69 or so, 70-ish degrees more than it is on the surface. So anything that is measuring has to actually work. So everything has to work at those higher temperatures. Okay? So we are working in much more extreme situations than any other engineers out there. Maybe we're not necessarily competing with NASA, but yeah. Other than that, drilling on Earth is still easier than drilling on Mars, but other than that, we are going into extreme situations. Right. And then, in terms of computation, there's traditionally what we had was theoretical knowledge. And theories typically have to be verified, but it's still knowledge that we can kind of work out by writing down on paper. And then there's experiments. You simply go and test something. And this third leg, it's called third leg of science, computation, is like, oh, I can actually virtually simulate what's happening. And that actually makes it easier for me to actually turn things on and off. I can say, oops, let's remove gravity term. Okay? You have to work quite hard, or you have to work in NASA to turn off gravity. Okay? So in that sense, computation allows you testing that otherwise wouldn't be possible. And it has become important. And I'm actually going to play this little movie by Dr. Oden. It's literally 2 minutes long. Oh, okay. That's odd. Apparently, okay. There we go.
So what happened toward the middle of the 20th century, and particularly in the last 25 years, was the advent of scientific computation. People learned how to take theories and turn them into mathematical languages, which could be put on a computer. Could be discretized and processed by a digital computer. The computer made possible a huge extrapolation of man's ability to use theory and to use observation.
I'm going to play the whole
I would say my biggest role model was my father and my grandfather. We were a close family. They spent a lot of time with their kids. They taught us the value of education. And I guess my younger life, I wanted to be as much like them as possible. I really enjoy working with students. It's invigorating. It's energizing. I have to explain things to students and I find out what I don't know. So you have to put things in words in a way you think you're conveying information. And you realize, well, maybe I better patch up some things I thought I knew. So the thrill of learning something new is why people go to a university and why they stay there.
So Dr. Oden is at the Institute for Computational and Science and Engineering. And actually, they didn't tell you why he's famous. But he's really famous for finite element methods, which are at the core of most of the simulation, especially in mechanics. So the group that is in DUT that works in that is one of the best in the world. So, all right. So then there is a lot of jokes that actually highlight the importance of computation and the way, why is it actually kind of cool. And so I'm gonna throw in one of those before we are done with this class. So 3 women, a physicist, engineer, and computer scientist are traveling in a car. And suddenly this car starts smoking and stops, and they individually try to solve the problem. So physicists say, well, this is obviously a classic problem of torque. It has been overloaded beyond the elasticity limit of the main axis and just sits there. Engineer says, no, let's be serious. The matter is that we have a burnt spark connecting to different pieces in the car, and this can be easily repaired just by hammering, trying to do something. And computer scientists say, well, what if we get off the car, wait a minute, and then get on and try again. There's this reset button that is actually really helpful. So programs you can restart without really destroying much. You can always redo, and that actually enables you to test various situations, which is the helpful part of computation. So with that, I'll stop here, and I will see you on Friday.